welcome to our introductory section for our awesome MySQL for data analysis course. I'm super psyched to have you here with me, and I hope you're ready to get your MySQL going. Let's get things started with a few questions that plague every data scientist's mind. We have a lot of details to cover, such as what is MySQL, what is data analysis, what is programming for data analysis, and a lot more. But for now, let's get started with something simple and easy, an introduction about this course. One of the most important questions about the topic is what data analysis or data science jobs are available. This is something very significant since lots of people are seeking data analysis and data science jobs right now. As for the second question, why do we need programming for data analysis? Of course, that's a very important question, but we're going to get to it in just a bit. And on top of that, there are a whole lot more questions that are probably running through your mind right now, but we'll get to them in a second. Let's answer first the question on job availability in data science and data analysis. Let's write here data analysis jobs. And let's see how many jobs are available. There are over 6,000 jobs in Germany alone. Let's change the country to the US and see. We have now 190,000 jobs available. Now, what does this mean? There's a high demand for data scientists and data analysts right now. So this is a very impactful and important career simply due to its current job market. And as you can see, it's going to have a lot of growth. So coming back to the questions, let's continue to this next question. Why do we need programming for data analysis? To understand this and to answer this, let's first understand an important concept that underlies everything related to data analysis. First of all, what are we analyzing? Are we analyzing a small number of data points or a large number of data points? Nowadays, it's usually the latter. It's usually a large amount of data, commonly called big data. Now, let's understand what exactly is big data. Well, big data is basically data at an extremely large scale. So instead of having 10, 20, 30 data points, you'd have 10,000, 100,000, a million data points. So again, very large. And since we have a huge amount of data points, we have an overload of information. And the main focus of data analysis and data science is to break down and analyze all those data points efficiently. Here's an example. See, you're given two Excel files. One of them is a small file with only a few data points, while the other is quite a large file with a lot of data points. If you were then told in the small file, please find the smallest value when it comes to the number of borrowers. Because we have a small number of data points, it's quite simple and easy to find the smallest one. But what about the other file? This large file has over 100,000 rows. And the file also has empty and null values, and the data isn't sorted or organized. Filtering through the data in Excel is very complicated and complex, and it can waste a lot of time. Again, it can be easy for small data, but for a large number of rows like this one, you need a new tool. And that's where programming comes into play. Using programming languages like MySQL is hands down the best way to analyze thousands upon thousands of data points without much of an issue. And this is just the tip of the iceberg. Jump into the next video to know now why data analysis in MySQL will change your life. See you there. Hello everyone. Welcome back to our course on MySQL for data analysis, and let's carry on with this introduction. Now, carrying on from our previous video, we'll continue with the questions that we all have in our heads right now. Next up, we ask why use SQL for data analysis, and specifically why use MySQL for data analysis. Let's start by asking why use SQL instead of other programming languages like Python or R. Both Python and R are programming languages, implying that they don't communicate directly with databases. Python and R focus on logic, filtering, and processing data. SQL, on the other hand, communicates directly with databases. So why does this matter? Data science is dealing with big data. This is our biggest problem. And could you imagine working in the data analysis field without databases in which all the data is stored? It's something that doesn't really make sense whatsoever. Data science without databases is quite meaningless. So for this reason, SQL beats both Python and R simply due to its ability to communicate directly with databases. Now, knowing that, Could you work in data science without databases? Well, certainly not. And that's why using MySQL and SQL for data analysis is so powerful. But in our next video, we'll tackle the big question. Out of all of these languages, why MySQL? Well, I'll see you there. Hello everyone, and welcome back once again to our course on MySQL for data analysis. Again, let's keep on with our introduction. We talked previously about why using SQL for data analysis is so powerful. But now let's tackle the question of why specifically MySQL. Well, before answering this question, let's take a short tour on the history of MySQL. You see, MySQL was first conceived by a Swedish company called MySQL Lab. In 2008, MySQL Lab was acquired by Sun Microsystems, and in 2010, MySQL ended up in the hands of Oracle after Oracle bought Sun Microsystems. A little note, MySQL is free, but it's not open source, simply because it uses a closed development model. This means that you can use it for whatever you want, be it studying, commercial purposes, anything you need really, but you can't modify the code or the models inside it due to it not being open source. So now that we know a little bit about MySQL, let's tackle the following. Why MySQL for data analysis? Before we get to it, let's remember this. When we work with data analysis or in data analysis, there are three important steps that must be covered always. First, we have to collect the data, then we have to clean the data, and finally present the data or visualize the data. Now, MySQL allows you to do all of that in just one package, and that's what makes it great. With MySQL, you can collect, clean, and visualize the data all in one place. Speaking of each point in specific, you can import the data from a wide range of sources like CSV, XLS, which are Excel sheets, or XML, directly into MySQL for your analysis. Also, once the data is gathered, you can filter through all of it, and if necessary, perform some cleaning in your tables. Last but not least, you can visualize your data once it's all prepped and analyzed, making MySQL a really powerful tool. But don't you start worrying about how to do all of that just yet. We'll get everything covered over the course of these next sections. So, why MySQL for data analysis? Simple. Through one language, you can collect, clean, analyze, and visualize your data in one fell swoop without having to turn to any other tool. And honestly, that is what makes it great. And just to give you an idea of what we're dealing with, in the next couple videos, I'm going to be showing you just how simple it is to use, how simple MySQL is to use, so you can get really excited for what you're going to be able to do once you finish this course. See you then. Hello everyone, and welcome back to our course on MySQL for data analysis. Let's carry on with this final part of the introduction. You may think that at this point, anyone who's a data analyst or data scientist has always and will always love programming. But as it turns out, there are quite a few who simply don't like programming. So what happens then? Well, maybe you think this question is a little funny. What if I don't like programming and I'm in the data science field? But there are data scientists who despise programming, thinking that programming for data analysis is something horribly complex. They think that learning programming for data analysis is, again, complex and complicated. But here in this video, I'll show you why it's a lot easier than you think. Also, I get told a lot something like, I don't like data analysis because programming is fundamental to data analysis and I don't know where to start or which language to learn first. Or how do I get started in data analysis without having any experience or even knowing my way around some basic lines of code? And as we know, there are a wide array of programming languages like C, C#, PHP, Python, R, MySQL, etc. And certainly a lot to choose from. So where to get started? Again, over the course of these next few videos, I'll show you why not only data analysis and programming for data analysis is quite simple, but also why MySQL takes the cake on being the easiest and most versatile language you can learn for data analysis. Trust me when I say that you don't need any previous knowledge or be especially skillful in programming to get started with MySQL. I'll show you just how easy it is to use for data analysis over the next few videos, so you can rest assured that you'll be analyzing boatloads of data before this course ends. Now, let me show you just how powerful MySQL is. Here's the MySQL Workbench IDE. Don't worry about installing it just yet, we're going to cover that in a few videos. This here is just to show you how easy it is to use MySQL. Now, before we get started, there's something really curious I want to mention about MySQL. Do you know the difference between the English language and MySQL? Frankly, it's not as different as you may think. Let me show you what I mean. If I told you I have a database full of DVD rentals, and we want to fetch all the data regarding different categories we have available, how would you write that sentence in English? Well, we'd write something along the lines of select everything from category. When we try to run this by pressing this button here, well, we get an error saying that everything is unknown. And well, who would have thought that MySQL could get philosophical? I'm just kidding. You see, just like any other language, sometimes you need to change a few things around. Let's remove everything and then replace it with an asterisk, which is how MySQL understands the term everything. In other words, everything in the English language is asterisk in the MySQL language. So let's run the comment again and see. Unbelievable. With just that one tweak, we can see all the categories like action, animation, children, family, comedy, games, etc., you name it. And in under 1 minute, and just by using one line, we performed some basic data analysis. How cool is that? Now, let's say you want to do the same, but instead of categories, we go for customers. As we write in English, select everything from customer. I expect you'll be able to guess what will happen if we run this. And there you go. We get the same error. Why? Because everything should be an asterisk. Remove everything and add an asterisk, and there you go. We get all the details from the customers, such as first name, last name, email, etc. Very, very awesome stuff. And another example, what if we have a bunch of numerical data and we need to sum it up? We can write sum. What if we want the average value of a whole column? We can write AVG, which is average only abbreviated. See, the difference between English and MySQL isn't that different. Now, let's come back to our slides here and answer our previous question about if you need programming for data analysis. You can see how easy it is to learn MySQL and apply it for data analysis. You don't need to master Python or R or any other language or even be familiar with them to get started in this field. Honestly, with MySQL, you can go unbelievably far in this field. Now, I hope that you can see just how powerful and simple MySQL is. In our next video, we'll take you through the projects that we'll cover throughout the course and get you on your way to becoming a great data analyst. See you then. Hello everyone, and welcome back to our course on MySQL for data analysis. Now that we're through with the intro, let's give you a rundown of what we're going to do throughout the course. In the first project, we'll be using MySQL to tackle the student loan crisis in the United States. As of March 2019, federal and private student loan debt reached a staggering 1.9 trillion US dollars. That goes hand in hand with the fact that education in the US is rather expensive. So expensive education plus lots of loans and debt leads to crisis, and that's what we'll be analyzing in this project. To add a little bit more context, those $1.9 trillion in student loan debt are spread out across around 44 million students. That's more people than there are currently living in all of Canada. That's unbelievable. Now, the student loan story goes way back to the space race in 1957 when US President Dwight Eisenhower approved a bill allowing students to borrow money from the government to be able to attend college. But as demand grew, so did the prices and so did the amount of money students had to borrow. Once again, all the makings of a crisis. But moving on, what exactly will we do? Well, now that you know a little about the backdrop of the student debt crisis, in this project, we'll focus not only on how to create queries to check if the students are applicable to get a loan according to their age, but also take a look at the impact of student debt on mental health. A nice 2-for-1. For our second project, we'll take a look at which state in the United States has objectively the worst drivers. Now, I know you can say that in my city, the drivers are the worst, and I'm not saying they're good drivers, but that there will be one place which houses the worst of the worst drivers. And we'll find that out just so you can avoid driving there if at all possible. Not only are you going to learn MySQL in this course, but also be able to identify which places are most likely to give you road rage. To give you an idea of what we're dealing with, here are a few stats. In 2012, there were 5.6 million car crashes in the US alone, out of which about 4 million involved only property damage, 1.6 million caused injury, and around 30,000 ended in death. Very unfortunate. So, using MySQL, we'll do the following. First, find out which state has the worst drivers. Here we'll be able to see as well which drivers have been flagged as being drunk or having been drinking at the time of their accident. Second, we'll find out the percentage of drivers involved in fatal accidents who were tagged as being distracted at the time of their accident. This can mean talking on the phone, texting, or just generally not paying attention to the road. Last but not least, we'll also determine which drivers were driving over the speed limit at the time of their accident. Hands down, a great way of breaking down all the driving information to keep you safe. As for our third project, we'll go old school and tackle sales in a DVD rental store. Here, we want to help the sales and marketing teams identify VIP clients and all their information to improve their sales quota and help them reach their sales target. The plus here is that it's a solely commercial project, so it's a skill you can transfer to whichever current market nowadays. On top of finding VIP clients, we'll also find out which movies are in high demand and constantly being sold, and also gather all the information about sales customers and employees. Suffice to say that we'll be doing all of this using only MySQL, and throughout the course, discovering more about queries and MySQL functionalities. So join us in the next video where we'll discuss the logic behind SQL queries. That way, you'll be more than ready to take on the whole course. I'll see you then. A little bit about SQL. SQL is a declarative language. But what does this mean? SQL is a high-level programming language. Do you remember us talking about the similarity between SQL and English? Well, I'm not saying they're one and the same, but the way SQL works and why it's a declarative language is that the queries logically describe the questions to the SQL query optimizer. For example, when we write a query, SQL basically translates, or describes, what we read to what the SQL query optimizer understands. Now, don't worry too much about understanding the SQL query optimizer. It's basically the element in the core of the IDE that is able to execute the queries. Last but not least, it determines the best method to physically execute the query. In other words, the optimizer, after analyzing the query, runs it in, you guessed it, the most optimal way. So when we write something like select everything from category, as we did before, it gets described and translated to then get optimized and finally executed. Let's look at it a bit more visually. We can see here a sort of data cycle for any given query. We start off with data access logic here at the right, which can be interpreted as a web app, but we don't really need to get into that. What we need to know is that the web app sends out a statement as a query to a database, such as select everything from category. That query then jumps into a database, first to a parser, which breaks down the query into its separate parts. Then down the query tree it goes towards optimizing and finding the best way to execute the query. Now, if the query has already been executed, it jumps to an execution plan cache, further speeding up the response time. If not, the now optimized query jumps into an executor to execute the query and provide the results back to the web app. That's pretty much how the queries run in and out of databases. Now, knowing this, I think we're ready to tackle some of the bigger topics, such as our next video where we will differentiate relational from non-relational databases. We're almost done with the building blocks for this course, and we're ready to power through. So, I'll see you in the next video. Simply, here's an Excel file, or what an Excel file looks like. And here's what a Word file looks like. In an Excel file, you can see that the spreadsheet is composed of different rows and different columns. And within them, we have cells which will ultimately contain data. On this Word file, on the other hand, we're only capable of putting a long string of data, and that's it. You can write all your data without so much structure. And that's really basically the difference between a relational and a non-relational database. I'm guessing that the comparison wasn't what you were expecting, but yeah, I'm guessing you're pleased to know how simple the difference can be. So let's get into relational databases a little bit more. See, here inside the database, we have something that can be viewed as, well, this. As you can see inside the database, we have a number of tables, and within each table there are rows and there are columns, and within them, cells with data. It's something quite organized and very structured. And this is what makes relational databases what they are, their structure and organization. On top of that, each table is considered to be normalized, meaning that not only do they exist, but they exist in relation to other different tables, hence the term relational database. So what about non-relational databases? We gave the example of it being like a Word document in contrast to the Excel file that is relational databases. The data in non-relational databases are known for containing data that's not structured. Again, like a Word document doesn't itself structure data. The key here is that non-relational databases can contain anything except tables. So it's like that random drawer we all have in our house. You know the one where you put everything that is seemingly out of place and can contain anything from paper clips to old receipts to lip balm. That doesn't mean non-relational databases are useless. They're just great. They're simply great due to the fact that they can contain anything, no matter the type. So going in a bit deeper, what's the difference now between SQL databases and no SQL databases? Again, Excel versus Word. SQL databases are relational databases, while no SQL databases are non-relational. Now, another difference between the two of them, SQL databases are capable of handling medium-sized databases and files, whereas no SQL databases are more suited for large or extremely large databases. And, well, examples of SQL databases are, of course, MySQL, PostgreSQL, SQLite, SQL Server, etc. For NoSQL, for example, you can use MongoDB or Elasticsearch. And, well, one final thing to talk about in this video, how many languages are used in SQL databases? Thankfully, for SQL databases, there's only one, SQL. We can write a query, like what we wrote a few videos ago, which is select everything from category. This query is used in MySQL, but it can run well in PostgreSQL, and SQL Server, and all other SQL databases. Sure, there are some slight differences between one and the other, but nothing too difficult. It's kind of like saying soda instead of pop, or car instead of automobile. Little things. Now, with no SQL databases, there are many different languages that can be used, and it really depends on who created the database and for what purpose. To put it in the context of our previous example, it's like saying automobile in English and Schmetterling in German. Not the same language and not even the same word. And, well, that pretty much covers the differences between relational and non-relational databases, which, of course, since it's MySQL, I'm pretty sure you're capable now of judging which type of database we'll be tinkering with. Now, for our next video, we'll take on database management, one of the final pieces of this whole puzzle. I'll see you then. Look at this image here. On the right, or over here, we have the central database, which in our case is MySQL, which stores files and data. On the left, over here, we have all these end users who wish to access the database and retrieve certain information or modify certain information. In the middle, over here, we have the DBMS, or the Database Management System. To give you an idea of the importance of the database management system, let's imagine that person A over here and person C both want to add data to a file located in the central database. If they were doing it directly, there could be a lot of issues regarding duplication, errors, or simply even accessing the file. What goes on, really, is that user A and C both write the request to the database management system, which then compiles the requests and performs them in a much more organized manner, modifying the files in the central database just one time. In short, it controls basically the flow of users from over here into the database and avoids turning the database into a complete mess. Now, a little tip, if someone asks what's the relationship between a database management system and MySQL, well, the MySQL framework is a database management system. How cool is that? I mean, there are a lot of different database management systems, but MySQL framework is definitely one of them. We've seen what goes on in a database, but what happens when we add a database management system into the mix? You can see here that a user sends out a query like select everything from category through a web app, through a website, through a software application, and it's then translated into SQL. Then it goes along into the database management system for processing, and then finally into the database to fetch the information. Now, once the data is fetched, it travels all the way back first through the database management system, then interpreted into SQL or through SQL, over to the web app, to the software application, to the website, whichever, and then finally back to the user. Now let's look at it in a different way. Here we have the application on one side and as well MySQL on the other. The application inserts, updates, deletes data, and sends that information request over to MySQL, which processes the query of insert, update, or delete. Pretty simple, no? Now, capping off this whole theory, let's go a little bit deeper and talk not only about database management systems, but relational database management systems. Now, what does this mean? Relational is the key here. Now, here's a simple example. We have 3 separate tables here, yeah? We have employees, we have department members, and we have departments. In employees, we have an employee called Alice, and her ID number is 815. As you can see, it seems that Alice is a busy person who works in 3 separate departments. An error? Maybe, but that's a question for later on. The key here is that this being a relational database management system, all 3 databases are related to each other, and it implies that if there's a change in one, there's noticeably going to be a change in others. So the difference between a simple database management system and a relational database management system is, again, quite simple. The database management system stores data as files, whereas a relational database system stores data in tables. So imagine if these were separate files, getting them to connect to each other would be a mess. Since they're all in tables, though, it is oh so much easier. And believe it or not, we have covered quite a lot of theory on SQL, on MySQL, and I hope that now you're ready to get started with the nitty-gritty data analysis with MySQL. So, what do you say? Are you ready? See you in the next video. Follow. First, we're going to install the MySQL community server. Then, we're going to install the MySQL Workbench IDE. And finally, we're going to connect both of them. Now, before we get into the installation, you should know the difference between MySQL Server and MySQL Workbench IDE. You see, MySQL Server serves as the database itself, whereas the IDE is like the visual prompt that allows us to communicate with the database by clicking around and or sending commands. Note that you can also use the command prompt instead of the MySQL Workbench IDE, and I'll show you just how it looks like. Now, using the command prompt in order to communicate with the MySQL server has a few disadvantages, although a lot of people like to use it. I mean, using the workbench, you can create tables, run commands, and use a lot of features just by clicking around. Whereas through the command prompt, you had to manually type everything. And correctly, I might add. And yeah, there are a few people who prefer running it through the command prompt, and others through the IDE. In this course, though, we'll focus on using the IDE, the MySQL Workbench IDE. So let's go to the downloading. So let's write here on Google, download MySQL Community Server. We'll click on the first link and make sure you're downloading for the Windows version. Now go to the download page and click on this first download button. It will lead you to a page asking you to log in or sign up, but you can skip it by clicking here on no thanks, start my download. Download, 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 open it and click on run. You'll be then prompted with this screen. By default, it marks the developer default over here. Leave that as is and click on next over here. And now you'll be prompted to check the requirements. Now, again, click on next. So if you don't have C++ installed, MySQL, this wizard will give you the option of installing it. But you don't need to go anywhere else, since MySQL will do it for you. You can, if you don't have it, you can just click on install right here and it will do it for you. So once that's set, you'll see this screen, in which you just click on execute and the whole list over here will start installing. So click here and all this will go running. Once it's complete and all checked, we click on next. Now it's time to configure the network. Here, we're going to do the difficult task of not touching anything and only clicking on next. Then you'll be prompted with an authentication method, and you guessed it, just click on next again. Now we get to the fun stuff. When we have an IDE installed and we want to connect to the MySQL database, the IDE has to have a password over here. Where it says MySQL root password, that's where you write the password which you will use to connect the IDE to the database. Suffice to say, you need to remember it from here on out. Right? And repeat, and we click on next. Next up, a screen about Windows Service, and we're back to just clicking on next. The installer is smart, so we don't want to tinker too much with it. So we click on next, and we're in the final step over here. Click on execute to apply all the configurations, and once that's done, we click on finish. It's not the end though. We get to another screen on router configuration, so we just click on finish. And we are still not finished. We should now run a quick test to make sure everything is working properly. The username is root, and the password is the one you put a few prompts ago. Then we click on check over here. If all is well, and it should be, you should get a little green sign over here saying that the connection succeeded, and that means the IDE is running well. Finally, we click on next. And for the last time, we click on execute over here, and we are all set. After the setup is complete, let's run it. Search MySQL Workbench. Click on it, and this is what will pop up. This is the IDE. Now, we'll connect the workbench to the database. You can see that there's already a local instance created. We won't dive too deep into that. Suffice to know that here you can see all your tables. Let's set up a new connection though. If you click on this button here, you'll get this prompt. It'll establish the connection name as Maradona Player Connection. If I click on Test Connection, you'll see that the connection is successful. Now, if it asks you for a password, you can click on Store in Vault, and here we write the password that we used previously. Now, let's double-click on our newly created connection. When we double-click, we're introduced to the screen in which we'll spend the most time in this course. Congratulations! Now, the next video is for those of you who are running Mac OS and want to install MySQL and the IDE and the Workbench IDE. If you already installed it, you feel free to skip over it and let's get going. So, I'll see you there. First, we'll download the MySQL database and install it. Then, download the MySQL Workbench IDE and install it. And last but not least, we're going to make sure that the IDE and the database are connected. Again, this is an important step because it validates that they've both been installed correctly and that they're working properly together. So let's start with the first step. In Google, search MySQL Community Server. Click on this first link and choose your operating system, in this case, Mac OS. Now, you have several types of files, but we're going to download the first one. It'll take you to a screen asking for a login, but you can bypass it by clicking on this link below that says, no thanks, just start my download. And there you go, it's downloading. Once downloaded, you'll get this pop-up screen over here, saying that this package will run a program to determine if the program can be installed. Now, allow it, and now we get the installer rolling. So, over here, we click on Continue. Then we're going to click on Continue again, and then we're going to click on Install. Now, once you click here, it'll ask you about your Mac password. Enter it and install the software. Now, up next, it'll ask you about encrypting the password. Just feel free to see here the strong password encryption and click on next. Now, here is an important part. This prompt here asks you to set a password for the root user, which is the username for the MySQL database and IDE. This password will be prompted in order for the IDE to communicate with the database. So suffice to say, it's important you remember it. So type the password, type your password of choice over here, and click on Finish. Now, it asks you to add your MAC password once again, and click OK. And well, now you're done. You have now the MySQL Server database installed. Now, to make sure that it's installed, let's go to your system preferences and you'll see the MySQL icon all the way over here. Double click on it and you'll see that, well, you've already installed MySQL and it's in the latest version. And we're done with the database. Now let's go on to the IDE. Back to Google and let's search MySQL Workbench. Let's click on the first link and download now. So let's choose our operating system, which in this case is Mac OS. Now we're going to click on download. And once again, it asks you about logging in. And once again, you can click on no thanks, just start my download. Now, once it's complete, you're going to copy the IDE into your application folder. After that, open your application folder and double click on the MySQL Workbench. Once you do that, it'll prompt a pop-up, which is a security feature from Mac, and it's quite common to see it. So to solve it, we're going to go to our system preferences over here, and we're going to click on security and privacy. And this will come up. When you open it, you'll see that MySQL Workbench was blocked. So we're going to click on open anyway. And if it says it cannot be opened, just click on open. And there you go. Now you have the IDE up and running. Now, double click over your username and password right here, and you'll be prompted to add the password for root. Now, this is the password that you set during the installation process. Type it in over here and click OK. And there you go. Now you're ready to get started with the IDE. So, are you ready to get started with analyzing boatloads of data? Well, me too. So, I'll see you in the next video. What we'll be doing is we're going to start and stop the MySQL server using the IDE. And also, we'll be doing the same, but using the command prompt. So to start or stop the server using the IDE, we're going to click on the server tab all the way up here in the top ribbon, and then click on start and stop server or start up and shut down. That'll prompt a window with two buttons. One of them with which you can stop and then start the server, which is this one over here. If by any chance clicking on it, you get an error like this pop-up over here, it's really nothing to worry about. It just means that there's a bug inside the IDE. So we can just omit it. Now, how about we start and stop with a command prompt? It's quite simple, actually. So we open up the command prompt and we write this line over here, which is net start MySQL 80. To stop it, we just write net stop MySQL 80. Quite simple, no? To give you a breakdown, here we're specifying whether we want to start or stop. And this 80 over here, this is the version, which is the 8.0 version of MySQL. So what do you say we look at it live? Let's open the IDE. Double click on the user here. I have two, but that's from the example that we did in the intro. You can choose to use the other one, no problem. Now onto the server tab. Click on Startup and Shut Down. Here it says the database server instance is up and running. So if we go to the server and click on server status, we can see that the server is in fact running. That's good. Now back to the other screen and let's stop the server. Well, now you see I got this pop-up as well, which simply reflects again that there's a small bug inside the IDE. It may have something to do with this version of Windows. If you run into it, let's fix it this way. Let's open the command prompt and again, run it as an administrator. This is highly important. So let's run this command. I'll put the IDE and the command prompt side by side so you can see what's happening. Let's look at the server status. We can see that it's running and we want to stop the server. So how do we do that? In the command prompt, let's write net stop MySQL 80 and press enter. You see that MySQL is stopping. Now, if we refresh the status of the IDE over here, we can see the server has in fact stopped. If you look at the schemas tab here, we can see that there are no databases and it outright says it's not connected. Even by clicking on reconnect, it'll say it's not connected. Now, let's start the server back up again. In the command prompt, we'll write net start MySQL 80. Press enter. And let's refresh here, and there you go, it's back online. We can now see in the schemas the databases that we have connected. Pretty cool, no? Now you know how to adequately start and stop connections. So I'll see you in the next video. We're going to see how to import a database into the MySQL server, and we'll also learn how to change the name of a database, or in other words, a schema. So let's open the IDE. From the Server tab, you can see here that there's an option to import data. Now, it prompts you two options, either to import from a dump project folder or from a self-contained file. Click on this button right here to search for a file. We'll import this file right here, which is the database with the DVD rental information. Select it and click on Open. Before we start importing, you need to choose a schema name, or the name the database will take once it's uploaded to the IDE. You can see here we have a series of default options, and we can pick from this list, but we can also provide a new name. Click on this button here, and we'll call it DVD Rental Database. Now we start importing. It can take a little time, so don't worry. And there you go. Through this here, we can see that the database has been imported successfully. But if we look at the schemas right here, it doesn't seem to appear. Why is that? Very simple. It hasn't refreshed. So let's click on this button right here to force a refresh. And there you go. Now the DVD rental database is imported and ready to go. Let's try that one more time just so you can see how quick it is. Select Open the file, and when it comes to choosing the schema name, you see it now suggests as well DVD rental database. But let's put in a different name, say Ronaldo. Click OK, start import, and there you go, the database has been imported. Now, we still can't see it here in our schemas. Why? Well, you guessed it. We need to refresh. So click on the refresh button, and there you go. This is something you'll be doing pretty much all the time since, well, you need the data inside the database to run your data analysis. And throughout the course, we'll be doing this a few times. Great stuff, and I will see you in our next video. Create a database and how to create a database table. The database that we will create will be called Top Players. And we will create a table called Top Century Player. In the table, we will have columns such as player name, international caps, international goals, and goals per game. Now, where are we going to get all this data from? We're going to use this table right here, which compares both Pelé with Maradona. So, what do you say we get started? Let's flip to the IDE. You can see that in the IDE, I have two users. One of them is a default user, and the other one is a customized user. This customized user we created in the introduction section. But for now, we will go with a default user, which again, everyone should have. So double click on the local instance seen here. Now we see this screen pop up. In order to do things from scratch, let's close this query so we can learn how to start a query. So click on File and click on New Query. This is what we're going to be using for the rest of the course. Now, do you remember when we talked about MySQL being very similar to English? Here, we will show you once again just how similar those two are. So, let's say I want to create a database called Top Players. In English, we would write create database Top Players. So let's highlight this and run this comment to see if it works. And well, there you go. You can see that running the comment worked perfectly, as MySQL understood exactly what we wanted to do. But here in schemas, we can't see the database. Why? Well, because it hasn't refreshed. So either click on the refresh button or right click and refresh all. And there you go, our wonderful database has been created. Now, our next step is to create the table. How would we go about doing this? Let's write create table top century players. But what about the columns? We're going to open some parentheses here, and in between them, add the columns that we want to be featured inside the table. Since we already have those from the slides, let's just copy and paste them. So we have player name, international caps, international goals, and goals per game. As a quick FYI, when we talk about caps in relation to football, it means how many games the player has played in. Now, all of these columns will have a certain type of value in which the data will be stored. So for example, the player name will certainly be a name, not a number or a decimal. So we have to, right next to the column name, define the content as a variable character, which implies we'll be storing text, and the number of maximum characters, which won't really exceed 50 characters. As for the international caps, that will be a number, so we will choose integer. The same with international goals. But for goals per game, that can be a decimal. So we don't want to choose integer simply because it'll reflect only whole numbers. So we'll choose float. This will interpret the data as being numbers, but allowing decimals. Now let's create the database. Let's highlight all of these lines here and run them. You see that we run into an error saying that no database was selected. And indeed, we tried to create a table but didn't tell MySQL in which database we want the table to exist. How do we solve this? Simple. Right-click on your database name and click on Set as Default Schema. You'll see that the database name is now in bold. What this means is that for every query you write from here on out, it'll assume you want to run it within this database. So let's highlight this again and run it, and there you go. Now we can see that the table has been created successfully. Once again, we see that in this panel here, under tables, it doesn't list our recently created table. What do? Refresh, and there you go. Now, there's another way of selecting in which database you want to work. You can either do as we did and select default schema, or we can do it through a query. We write use, and then your database name. This will let MySQL know you plan on using that database for a certain query. But for now, we want to use our top players database. So let's write use, and we can actually drag and drop the database into the query. That way it automatically puts the database name next to use. Great. Now we want to select everything from top players. If we highlight this and run it, look at what we see. Our beautiful new table inside the database that we created. Now, there's no data inside the table because we haven't added any yet. So let's get to this. In English, we'd write something like insert into top century player and then our values. And in between parentheses, we'll add the columns, player name, international caps, international goals, and goals per game. But what about the values? Since we have 4 columns, we need 4 data points. So this first one is player name, and let's go with Pelé. I put it in between quotes to let MySQL know that this is a string of characters and it should be treated as such. Next, international caps, which is a number. let's put 20. For international goals, let's say 100, and for goals per game, since it's a ratio, let's put it at 0.66. So let's highlight and run this, and there you go. We've successfully inserted this data into the table. Now, let's highlight and rerun this query, and there you go, our table has new data. Awesome, isn't it? So tune in to our next video and keep on learning and mastering MySQL. I'll see you then. What we're going to be doing is, again, inserting data into our MySQL database. We're going to use a MySQL query to know which player played more than 90 international football games. And we're also going to use a query to know which player has a 50% or higher goals per game ratio. So how about we jump right into it? You see that I've already written all of the data we need to put into the table. You also don't need to do it from scratch, since in your file you should have all of this already. Here's a little nifty trick. Say you want to insert data into your table, but you don't want to write all of this. How do you do it? If you go on this left panel, under your database, under tables, you can right click on it, and you can go to Send to SQL Editor and click on Insert. Now, the whole query pops up automatically and you only have to insert the data you want. Pretty awesome, isn't it? So let's delete these placeholders here and start adding our data. Since we already have those values, we can just copy and paste them. If not, well, they're not that long, so typing them up isn't that time consuming. Now, let's highlight this and run, and there you go. Now we can see that 2 rows have been affected, and that means that we've inserted the data into our table. Let's check and see if it's what we want. Let's run a select everything query again. You should know by now how to write this. Select everything from our top century player table, highlight and run, and perfect. We can see that our table now has the data we wanted. And that's it for our first task. Now, for our second task, we need to write a query that lets us identify which player has played more than 90 international football games. Let's add the task as a comment in the IDE, that way we don't switch back and forth. Now, to add a comment, we just write before the sentence, a double dash and a space. See how it turned all blue? Comments are useful in order to give other people directions as to what you're doing with the code. And MySQL knows that it's a comment, so it won't execute it. Now let's write this query. I'll take a very informal road since it's a simple and easy way to learn. We'll write it as we would in English. So we write select everything from top century player where international caps are over 90. So let's highlight and run this comment here. As before, I'm guessing you'd expect what will happen. So we can see here that it says that everything is not defined. That's simply because everything is in English. And in MySQL, you guessed it, it has to be an asterisk. So let's switch it up and see. We highlight, we run, and it's perfect. We can see that both players have played over 90 international games. Even though we're doing this with a small amount of data, this is applicable to absolutely anything. For our third task, let's see which player has a goals per game score of over 50%. That means that we want to find out the players that have scored in at least half of the games that they participated in. So let's add the task as a comment. We want to find the players that have a goals per game score of over 50%. So let's select everything from top player century, where goals per game, and perfect, we can see the result is 1 player only, meaning that out of the 2, Pelé is the only one to have scored in over half the games he participated in. As you can see, these types of data analysis in MySQL are really easy to do, and possibly are going to be the most common ones you'll do. So I'll see you in the next video to continue learning MySQL. I'll see you there. two types which are the most common: numbers and strings. But for now, let's focus on strings. As you can see here, there are a lot of different data types which involve strings, such as tiny text, such as character, variable character, etc. And odds are you won't be encountering most of these frequently. Let's focus only on one. This one over here, the variable character type, since it's the one that's going to be most commonly used. So knowing this, how about we compare variable character over here to character? Let's say we want to add a string called AB, like the two letters A and B. One with a data type of character with a 4-character length. As you can see here, it says fixed length string. So we specify that we want it to have 4 characters. And we're going to add another one that has a variable character with, again, the same AB. Now, what would be the result? So since we only have 2 characters, MySQL adds the other 2 as spaces. On the other hand, variable character over here is for variable length strings. And running the same AB query, you get AB without the extra spaces. Now, the rest of the string data types are very uncommon, so let's better talk about the number data types. You can see here, as with string data types, that there are several number of data types, out of which only a few are really common, which are integer over here and float over here. Now, the main difference is that integer over here returns data as whole numbers, while float over here can return data as decimals as well. So, for example, if we would run 9.2 as an integer, it would return 9, whereas float would return the full 9.2. But now, what's the difference between float over here and decimal over here? Well, let's see. We're going to create a table called materials, and in it we'll add columns such as ID, description, and cost. This is over here the query that we're going to use. Now, I want you to keep an eye on this column over here where we're going to be using a decimal data type. So let's switch over real quick to the IDE and show you the difference. As you can see, I already wrote down all the code, so you can just quickly see the difference. We have 3 columns. The first one is materials ID. The second one is the materials description, and the third one is cost. We can see that materials ID is an integer, while the description is a variable character. What we're interested in, though, is this final one called cost. So what do the numbers after the decimal mean? Well, the 4 refers to decimal places. So when calculating, MySQL will return a number with no more than 4 decimal places. The 6, on the other hand, refers to the total amount of numbers it will return, including the decimal places. Let's see how it works. Let's remove this comment and get started. Highlight and run to create the table. We refresh and we see that it's all set. About this auto increment and primary key, don't you worry about that. We're going to cover that in a bit. So let's insert this data, highlight and run, and select everything from materials to C. Highlight and run, and see how the data in the cost column adapts to the decimal parameters? No number has more than 6 digits total, and they all have 4 decimal places, as we had previously stipulated in the decimal query. So what happens if we add a whole bunch of numbers? Let's see what happens. So let's highlight and run, and now let's select everything again. See how all the values after the 4th 9 got left off? That's because we specified that we didn't want more than 4 decimal places. So what about float? The float data type will accept any number, regardless of length. So let's do a real quick summary of data types. Where can we add data types? Simple. When we create the table, we can specify the data type for each column right after naming it. And what's the difference between float and decimal? Well, float allows any number, whereas the decimal limits both the total amount of digits and the amount of decimal places. See, MySQL is really intuitive and really easy to use. So jump into our next video and keep on learning. I'll see you there. Now, Previously, we've done it in a very informal way, comparing it to writing in English, but now we'll dissect it. Now, the select statement has 4 separate parts: the select, select list, from, and table name. The way MySQL reads the command is that it starts with the from clause over here, basically locating the table within which you want to select the data. Then it selects what you requested. So in order to see exactly how it works, let's jump into today's task. We'll be using the select statement to do the following SQL queries. First, we'll find the names of all customers from our customer table. Then we'll write select statements to query data from multiple columns like first name and last name, email, etc. Last, we'll join all the data together using concatenate and place it into one column called full name. So without further ado, let's jump into MySQL and run the queries. Our first task is to find the first names of all the customers from the customer table. So let's start by running a query. Select everything from customer. When we highlight it and run it, we get an error. Why? This error is saying that the top players database has no table called customers. How do we fix it? Well, simple. We need to tell the IDE which database we want to use. We had previously set top players as the default schema, and now MySQL assumes we want to continue working on that table. You can see that the top players database is highlighted and in bold, and when it's bold, it's basically telling us that the IDE is using that database for our upcoming queries. So, to fix it, we do the following. We'll write use, then drag and drop the DVD rental database onto the query. Let's highlight and run, and there you go. Now you can see that the DVD rental database is in bold, and it's being used for the upcoming queries. So now, if we highlight and run the comment here, it runs perfectly. So with the first task, we need to find the first name from the customer table. Now, inside the customer table, we have a column called first name, and that's specifically what we're looking for. So we select first name from customer, highlight, run, and there you go. We're already done with the first task. So for our second task, we're going to write a select statement to query data from multiple columns. But how do we do that? In English, we'd write select first name, last name, and email from customer. So let's highlight and run, and amazingly, there you go, it ran perfectly. You can see how easy MySQL is to learn and use for data analysis. Now, what happens if I want to do the same thing but without typing all that much? By writing select and then dragging and dropping the column names from the schema with respective commas. Then we type from and then dragging the customer table. We highlight, we run, and there you go. Amazing, isn't it? So let's comment that out and jump into the final task for this video. Now, we're going to concatenate first and last names into one column. So we need to select and then write out concat, which is the way MySQL interprets concatenate. And in between these parentheses, we're going to put first name and last name. But we also need to select the email from its column. So what happens if we run this? Well, it runs like a charm, but there's a slight issue. Although it concatenated great the first and last names, it put them together without separating one from the other. Look at Aaron Selby over here. There's no space between the names. So what we can do is simply add a space in the concatenate command, like so. We run this and there you go. But say we want to go the extra mile and spruce it up a bit. Let's rename the column to suit our process better. Now, At the end of the concatenate command, we can write as, and, well, pretty much whatever you want. So let's say dinosaur, because why not have a little fun while we're at it? Highlight and run, and there you go. But, well, in all seriousness, let's put full name as the column name, so highlight and run, and that's pretty much it. You can see how easy it is, once again, to be running these MySQL queries. I'll see you in our next video. So, we'll see how to modify one and multiple columns. We'll learn how to add one or multiple columns. We'll learn how to rename a column and how to delete a column. So what are our tasks? First, we're going to add a column called car model at the end of the vehicles table. We'll add two columns, color and note, to the vehicles table. We'll then change the note column to a not null column with a maximum character limit of 100. Then, we're going to change two columns, year and color, to reflect the following. First, the data type in the year column will be switched from int to small int, or integer to small integer. The color column will now have a max character length of 20, and we'll remove the not null constraint. And finally, we'll move it to appear after the make column. Last but not least, we'll rename the note column to vehicle condition. As you can see, there is a lot of work to do, so let's get started. Let's start with this first query here. We're going to create a column in the vehicles table. So for the sake of example, let's use the top players database. I have the code all written here to create a table called vehicles. So highlight and run, and there you go. Now, if you go to the schema and look for the table, you can see it or you cannot see it. If you don't see it, right-click and refresh. Now, we can see that inside the table there are three columns: vehicle ID, year, and make. This primary key right here refers to the vehicle ID column, and I'll show you what that's about in the next few videos. So, back to our example. Let's add a column called car model. How do we do that? What we need to do first is alter the table. So we alter the table called vehicles and add car model. Now, what would the data type be for this column? Since the model can have letters and numbers, it should be a variable character, with let's say a limit of 100 characters. Also, do we want the column to allow empty values? No. We want all the cells to have values, so we add a not null to the end. This forces the cells to not allow empty cells. So highlight and run, and there you go. Even though it doesn't appear yet, right-click and refresh, and you can see it now. We now have a column called car model. Now, there's another way to view the information of a table. If we write describe and then add the column name and run that command, we can see now all the information regarding the table, like columns, data type, null values, primary keys, etc. Carrying on, we want to add two columns, one called color and the other one called note, all in the same vehicles table. So we're going to comment out the first task, seeing as though it's already done. So zoning in on the second task, we need to add two columns. Now, you think that adding two columns means running two queries, but no. We can do all of that in just one, and it's quite similar to the previous task. So let's add here the color column with a variable character data type and a 50 character limit, which is more than enough. Now, at the end, we'll add a comma, and on a separate row, we'll add the new column. So here we go with add note. And again, the data type is variable character with a character limit now of 90. Now, both have to contain values, so we'll add the not null tag. And please do remember that after every column you wish to add, use a comma. With that, we specify that there is more than one part to the query. So let's highlight and run, and there you go. 2 new columns have been created. Now, we may not be able to see them, but let's remember, right-click, refresh all, and here they are. Here's the color and note. Also, if you write describe and then the table and run that comment, we can see all the characteristics of the table. Now let's move on to the third task, which is changing the note column to allow a maximum of 100 characters. So let's comment out this second task as it's already done. So carrying on, we need to alter the table called vehicles. Now, we previously used add, but add is to create a new column. Since we have the column already, we'll go with modify. And add the varying part is the variable character with the 100 character limit. So let's highlight, run, and there you go. Let's describe it and see. You can see now that the table allows 100 characters in the note column. Now that was a very quick task. Let's move on to the fourth task of this video. We're going to change 2 separate columns, year and color, and well, we have a lot of things to do. You may think that we'll write a whole lot of queries to do all of these things, but really, we'll just need to do a few things. First, we need to alter the table called vehicles. And first, we want to modify the data type of the year column. Now, we want to change the data type to small int, so that all we have to do is type small int after the column, and there you go. For the next one, we need to modify the color column to allow a character length of 20. So we write modify color variable character 20. Also, to this column, we want to add the possibility of empty cells. So to remove the not null constraint, we just write null after the variable character. Last but not least, we want the color column to appear after the make column. So to do this, we simply write after make. And in 2 lines, we did absolutely everything we needed to do. Let's see what the table looks like before executing this query. Look at the columns, the position, and everything. Now, let's highlight and run the query, and, well, let's describe it and take a look. What we needed to change was effectively changed. So, let's comment out this fourth task, and let's move on to renaming the note column to vehicle condition. So, we're going to alter the table called vehicle conditions, but will we use add, modify, or change? Well, it's not add because we already have the column. Now, in modify, we can make small changes to an existing column, and the difference with change is that the change tag allows us to rename a column, something that modify cannot do. So we're going to go with change. And after change, we write the column name, which is note, and we want to change it to vehicle condition with a data type variable character with a 100 character limit. So let's highlight and run, and let's describe the table, and there you go. You can see now that note became vehicle condition. As for the last statement, we'll talk about deleting a table. So let's comment these out because they're already done. Now, to delete a table using MySQL, we're going to use the command drop. If we write drop table and then our table name, MySQL will delete the table and all of its related data. So let's run this and see, and well, now we can see that the table has been removed, even from the schema. Awesome! Now, I hope you're enjoying this, and I hope to see you in our next video. See you then. at these images here. We have a table over here called customers. A table over here, let's say it's going to be sales, and a table over here, let's say HR. At the end of each table, suppose we have the same information, which are these over here. So each table in this scenario has the same last two columns. Right here, we have an issue because we're dealing with a lot of duplicated, or well, in this case, triplicated data. This here means that we're wasting space and memory, so it's best to avoid this. How? Well, using primary and foreign keys. The magic here is that by adding this one column, we can save a whole lot of memory. So the way out here is that by adding a reference, a primary key, to each of these three tables, it allows it to communicate with a fourth table containing all the data that's the same for each one. And they can now be linked with the data without having problem of duplicates. So the logic here is that this 101 primary key from the first table will be linked to the 101 in the fourth. And that's pretty awesome, isn't it? The best part is that we're able to store all of these references as numbers, so it's a definite plus. Now, it's worth noting the following. Primary keys will always have unique numbers within their respective tables, whereas foreign keys can contain duplicates, as you can see over here. Let's look at this example. In the customer table, you see that each customer ID is unique, whereas in the second table, there are a fair amount of duplicates. Let's look at it this way. In your phone, you probably have more than one type of contact information for your contact card. I mean, you probably have under your name, cell phone, home phone, maybe a work phone, email, etc. But there's only one you. So by looking up your card, your primary key, over here, you can get a lot of separate information, or your foreign keys, in one fell swoop. This is what you'd call a one-to-many relationship. So this was a very short little theoretical break, and in our next video, we'll jump in hands-on with primary and foreign keys in MySQL. I'll see you there. SQL to create two tables and connect them. So we'll be creating a table called categories, one called products, and the category ID will be the primary key here in the categories table, whereas in the products table, the product ID will be the primary key and the category ID is the foreign key. Now, I know it seems like a mess, but bear with me. You'll see it's all done real quick. So just to recap everything, we're going to be creating these two tables, categories and products. In the categories table here, this category ID is going to be the primary key. In the products table, we're going to have both a primary key called product ID and a foreign key called category ID. And that's how we're going to be linking these two tables. So let's jump into MySQL and get things started. First of all, let's create a table called categories, in which we have a column called category ID and one called category name. So remember that we're going to set category ID as a primary key, and it's going to be an integer. Category name will be a variable character with a 100 character limit and cannot be null. So let's highlight and run, and there you go, table created. Now let's populate it with data. Using this insert statement here, take a look at what will happen when we run it. We can see that inside the categories, we have a column called category name. And within category name, we want to add these values. So we highlight and we run into a problem. Category ID doesn't have a default value. Let's see how we can fix that. To do so, let's take this task up from the top by dropping the categories table. So drop table categories and let's create it from scratch. Now, what we want to do is for MySQL to insert data automatically into our category ID column. For that, we're going to use auto increment. Remember that we used this in a couple of our previous videos, and now we're going to show you exactly what it does. So let's highlight this and run, and well, all is well so far. Let's insert the data, highlight, run, and there you go, it worked. So let's refresh and select everything from category. And there you go. You can see that by using the auto increment, MySQL automatically added 1 and 2. Now, if we don't use auto increment, how can we do the same thing? Well, how about we drop the table and try again? If you don't or can't use auto increment, you can add the values manually. What we do here is that in the values query, before the category name values, we manually add the 1 and 2 and so on if necessary. You can add more again if you so need. So let's highlight and run, and now let's see. There you go, you can see our updated data. Again, with auto increment, it's a whole lot easier. So if you can go for it, do it. Now, what happens if we add a new row, but that has a repeated primary key? Remember that primary keys have to be unique. So what happens if it's repeated? Let's remove this part and just add this one. Let's run, and there you can see there's a duplicate entry for a primary key. Now, if we modify this bit and instead of it being a 1, we put it as a 10, then we can see that by running it, it's added correctly, no duplicate data. Now, let's move on and create the products table. Inside the products table, we'll have the product ID, product name, and category ID. And we'll also create a relationship between the tables. So let's just modify this code over here. We'll create a table called products. Within it, a column called product ID with an auto increment. And then a product name with a variable character, and a category ID that has to be a foreign key. To do this, we just write this. And there you go. Now category ID in this table is defined as a foreign key. And the last bit is to establish the relationship between the foreign key and the primary key. And to do that is quite simple as well. Let's write here references and reference the table categories, and within the table, we want to reference the category ID column, which there is our primary key. And that's pretty much how you build a relationship between two separate tables. Remember, the key here is knowing the difference between what's your primary and what are your foreign keys. And yes, that pun was totally intended. So I'll see you in our next video. See that the where clause operates like so. First, MySQL locates the table from which we want to fetch our data. Then it applies the condition that we've set. And finally, it selects the data that we need. So to get the hang of this, we'll do these following tasks. First, we'll use the where clause to find customers whose first names are Jamie. Second, find out which customers have the first name Jamie and the last name Rice. Last but not least, we're going to find the customers whose last name is Rodriguez or whose first name is Adam. So let's get started with the IDE. Our first task is locating the customers whose first name is Jamie. So we're on our DVD rental database, so if you don't have that as your default schema, feel free to load it up. Now, we want to find all the Jamies. For that, we'll write select first name, last name from customer, where first name is equal to Jamie. Highlight and run, and there you go. I mean, sometimes it amazes me how simple MySQL can be. And just like that, we did the first task. So let's comment it out and go for the second one. Now, this task asks us to find the customers whose first name is Jamie and whose last name is Rice. So like the previous one, but with an extra condition. So to save time, let's copy and paste this here. What we do is add and last name equal to Rice. Highlight and run, and there you go. Now, for our last one, we need to find customers whose last name is Rodriguez or whose first name is Adam. Now, how are we going to do this? Again, it's similar to the previous one. Copy and paste, and now we change this last name here to Rodriguez. We need this to be an or, and the first name to be Adam. So highlight and run, and wonderful, there you go. A simple, quick lesson on where clauses in MySQL. And without so much effort, you can see just how well you're picking all of this up. So I'll see you in our next video. For that, we'll use the order by clause to sort customers by their first names or last names in descending or ascending order. So our tasks for the day are these. First of all, we're going to use the order by clause to sort customers by their first names in ascending order. Then select the first name and last name from the customer table and sort the rows by the values in the name column in descending order. And last but not least, we'll select the first name and last name from the customer table and sort the rows by the first name in ascending order and last name in descending order. Just so you get an idea of how this order by command works, like how the syntax goes. Again, as always, first and foremost, what MySQL looks at is from. Where are we getting the data from? Then, in this case, it selects the data. And last but not least, before fetching the data, before bringing the data back up, it will order it according to what we require. So what do you say we jump into the IDE and get things started? So first, let's sort the customer names from our DVD rental database in ascending order. To do this, we select first name and last name from customer. But after selecting, we need to order by first name. And we want it to be ascending, which is ASC. Highlight and run, and well, there you go. That was quite quick. So on to number 2. We need to select the first name and last name from the customer table. It's the same as this previous one, so we'll just copy and paste it. And what else do we need? Well, we also need to sort the last names in descending order. So let's switch this to last name, and well, this needs to be descending, so DESC. Highlight and run, and there you go. Now, the last names are in reverse alphabetical order, so from last to first. And once again, that was unbelievably quick. So for our last quick task using the order by command, we'll select the first and last names from the customer table and sort the first name in ascending while the last name is sorted by descending. Tricky. So let's get to doing this. Let's copy and paste this to use it as a template. So we need the first name to be ascending and we need the last name to be descending. So let's highlight this and run, and there you go. And I must say that was a very speedy tutorial on how to sort data using MySQL. Well, I'll see you in our next video to take on a big challenge. I'll see you there. So our first task is to find the rental information of customer IDs 1 and 2. Also, we want to find all rentals with the customer ID or where the customer ID is not 1 or 2. Last but not least, we want to find the customers whose first name is Anne with an E, or Annie. So let's jump into the IDE. First, let's solve this first statement, which states finding the rental information of customers with an ID of 1 and 2. But where's our rental information? They're located in 3 separate columns: customer ID, rental ID, and rental date. All of these are taken from the rental table. So before we run this, I would just want you guys to make sure to be using the DVD rental database as a default schema. If not, well, it's going to be a little bit difficult to finish this. So make sure that the default schema is set as DVD rental database. So carrying on, let's highlight and run this query. Awesome. Now we have all the information about rentals. Although we have a condition set in place. We only want the information from customer IDs 1 and 2. And when we talk about conditions, we want to use where. So we need the information on the customers whose ID is 1 and 2. So we type where customer ID in, and here we open parentheses 1 and 2. Let's close parentheses, and that's pretty much it. Let's highlight and run, and there you go. Now we have all the rental information for the customers whose ID is 1 or 2. You can see how the in operation lets you look for data located specifically within certain criteria, which in our case was the customer IDs. Now let's look at the second one. We need to find all the rentals that are associated with all customer IDs that are not 1 or 2. How do you think we get there? It's actually quite similar to the previous one. So let's copy and paste the previous query. We want to select customer ID, and rental date from the rental table. Now, we need to get all data except customers IDs 1 and 2. So how do we do this? It's a lot simpler than you think. Instead of rewriting everything in a very complex way, we're just going to add here the word not. So we're asking for the info from all customer IDs not in 1 and 2. So let's highlight and run, and there you go. Now we have all the information for all customers that are not IDs 1 and 2, just by adding that one little word. Let's do this one more time, but with a third task. We're going to find all customers whose names are Anne with an E, or Annie. So first, let's select first name and last name from the customer table. Let's highlight and run, and now we can see that the first and last names of all the customers. But we only want those who have the first name Anne with an E, or Annie. Since there is a condition, again, we're going to use where. So where first name, and in between these parentheses, we'll add the values we want to search for. So we add Anne with an E, and Annie. Remember that since these are names, they have to be put between single quotes. That way MySQL reads them as a string. So highlight and run, and there you go. Now we have all the information for all those customers who are called Anne, or Annie. Wonderful, isn't it? Let's do a really quick review of what we learned so far. We've used equal, we've used less than, we've used greater than over here, we've used and, or, in, between, like, not, a lot of different operators. Just as an FYI, this null here, it will only validate that data exists or not. So it's nice to know, but you're not going to be using it that much. Now that we see it like this, we've done a whole lot, don't you think? Well, there's a lot more coming. So I'll see you in the next video. A couple of separate tasks. So first and foremost, we want to find the films whose rental rate is higher than the average rental rate. In order to do that, we have to find the average rental rate by using the select statement and the average function. Using the result of this first query in the select statement is the way in which we're going to find the films that we want. Second, we're going to find the customer ID, first name, and last name from the customer table, where the customer IDs from the rental table are with a return date equal to 2005-05-27, which is the 27th of May 2005. So how about we jump into the IDE and get started. First, we need to find the films whose rental rates are higher than the average rental. So let's select the film ID, title, and rental rate from the films table. Highlight and run, and whoops, it's film. So let's rerun. And there you go. We have the film ID, title, and rental rate. But we have a condition that states that we only want those films whose rental rate is higher than the average. But let's take it piece by piece. Let's write where rental rate is greater than 1, just for the sake of looking at the rental rate. Let's run the comment and see, and there you go. We can now see that films whose rental rate is higher than 1. We can also make it higher than 4, and let's see what we get. Awesome! All the values here are now higher than 4, but what happens if I remove these parentheses? Absolutely nothing, actually. But why use them? Well, in a certain way, they keep the code clean and it's easy to identify what's in your clause. But there's also a more important explanation, which I'll get to in a bit. So let's jump into the next part of this task, which is finding the average rental rate for all these films. Let's write select, and we need to select the average rental rate. In MySQL, we will use AVG, but we have two. Let's get the one with parentheses. We need the average of the rental rate, which is in the films table. So let's run this and see. Awesome. We can now see the average value of the rental rate, but we need to put here the value that we just discovered. So if I cut and paste this on top of the 4, what do you think will happen? Let's run and see. Beautiful! It worked great. So what happened? We used a select statement within a select statement. Now you can see why the parentheses are important. Without them, we could have generated an error. But why risk an error when you can just copy the final data? Let me show you why. So let's make a copy of this here, and we'll get rid of this clause. We know the real value comes from this statement, so let's run it and see. We can see the result is 2.98, and we'll add it in this query. So just to show you, what's the difference between one and the other? Well, one uses a number as part of the condition clause, while the other references an existing table. So you can probably guess which one will be more accurate. Hint, hint, it's the subquery. So let's move on to the second task. We need to find the customer ID, first name, and last name from the customer table, but we have another condition put in place. We need to find only those customer IDs whose return date is the 27th of May 2005. Also, all of this data is on a separate table called rental. Now we're piecing things together here. But let's break it down. First, we'll do this first part. So we select all of this and run it. So far, so good. Now what? We have a condition. So where customer ID in and let's run it with some dummy values. So I'll add a few random values. Run and good, it works so far. And let's get back to this in a second. So back to our task. We want to find the customer IDs from the rental table, or we're going to fetch the customer IDs from the rental table with a return date of the 27th of May 2005. Let's write this query. So we select return date from customer ID. We select the return date and customer ID from the rental table. Whoops, error. You gotta love the typos. Let's run it again and perfect. We can now see that the return date and the customer IDs. So let's start putting things together. The return date is set for the 27th of May 2005. So let's add the condition, where return date equals the date. Let's run it and see. Now we have a table with no data. Why? The data that we added as a condition is in a different format than the one that's being displayed on this table. You can see that the one in this select statement has a timestamp as well. So how do we fix this? We can do this by using the cast function. So we add cast, and in between the parentheses, we put return date as date. Same with a select clause. Let's run it, and you can see now that the time isn't being displayed, just the year, the month, and the day. Beautiful. So for our last step, we'll get rid of these dummy values and add this whole subquery between these parentheses. So let's clean this up a bit. We only need customer ID, so we get rid of this, and copy and paste this whole subquery into the in command. So let's highlight and run. And there you go. Now we have all the details the task required. Congratulations, you just executed your first subqueries. Pretty easy, isn't it? So join us in our next video to pick up a whole lot more. See you then. So in order to do this, we have a couple of tasks that are up ahead. Our first task is to find payments whose amount is between 8 and 9 US dollars. And for our second task, we'll also retrieve the payments whose payment date took place between February 7th and February 15th, 2007. It'll be easy, so this will be quite a short lesson. So let's switch now to our IDE. First, we'll tackle the first task, finding payments whose amount is between $8 and $9. First and foremost, let's select all this info from the payment table. On top of that, we'll add a condition. So we'll write where the amount is between 8 and 9. Let's run it, and there you go. It's easy and quick. With this between clause, you can filter data, explore data, you name it. Now that that's done, let's comment it out and let's move towards the next one. Now we need to find the payment the payment info between these two dates. Let's first select all the payment information, so all of these columns. We select them from the payment table. Let's run it and, well, there you go. Now let's add the condition. Let's add the where clause. Payment date is between these two. Copy and paste it. Remember to add the single quotes around each date. So we run this and we can see that there's no data. Perhaps there is no data in our tables for those dates. So what about 2005? So let's change 2007 to 2005 and let's change a couple of these months and there you go. Effectively, there was no payment data between those first two dates. And again, that's pretty much how you use the between clause. Short, simple, sweet. See you in our next video. This is specifically our tasks for today. We're going to create two tables. Table A is for Sarah's product basket, and table B is for, let's say, Ibrahim's product basket. Our second task is to use the join clause to find only the common product types purchased by Sarah and Ibrahim. So let's jump into the IDE. First and foremost, we have to create the tables and populate them with data. Let's first create a table called fruit sap. Let's run this and there you go. Refresh it and now we can see it here. Let's also set it as the default database. So use fruit sap and run. And there you go. MySQL will now use this database from here on out. This code here is to create the table, so nothing complicated. As you can see, they are simply create table queries with two columns and two queries to populate the tables. So feel free to highlight all of this and run it. And there you go. Now we have everything set up. Now let's select all the data from Sarah's table and we can see it's all there. Let's do the same for Ibrahim. Let's run it and yeah, we can see we have all the data that we need. Now, a question for you all. Do you think it's possible that using only one select statement, we can select all the columns from two different tables? Honestly, no. And let me show you what happens if we write one select statement to select all the columns from two tables. So let's write select column B and this one here. And from Sarah, we'll select column A and this other one. Now, select them from, well, which table? Unfortunately, it only lets us select from one table. If we add another one, it'll run an error. So let's run it and see. There you go. Error. To solve this, we'll use the magical join keyword. So we'll join data from two separate tables. Let's highlight this and run. And wonderful. Now we have all the details from all these columns in one place. We can see that there are 4 columns total and it selected everything. But the data seems to be duplicated. It seems that for every row in the first table, it brought all the data from the second table. We can see that in the numbers that all the data is repeated. Now, do you think that just by using join we can solve our task? Not at all. Not only does it duplicate the data, but we only need the ones that are repeated between both tables. So, how do we solve this? In order to make the join effective, we need to use the on command. So basically, what we need are the things that are in table A that are equal to the things in table B. So after this join, we use on to specify where we want the join. So we go on this table equals to this table right here. Let's run this and see. Wonderful. This is the data, the exact data that we were looking for. So what did we do here? We did something called an inner join. Basically, we asked MySQL to look for everything in table A that is also in table B. And as for the syntax, there are separate types of joins. But by writing join in MySQL, it automatically assumes it will be an inner join. So fetching all the data that exists in both columns. Pretty cool, right? Well, I'll see you in our next video to keep on talking about the other types of joins. I'll see you there. So, this is specifically our tasks for today. We're going to create 2 tables. Table A is for Sarah's product basket, and table B is for, let's say, Ibrahim's product basket. Our second task is to use the join clause to find only the common product types purchased by Sarah and Ibrahim. So let's jump into the IDE. First and foremost, we have to create the tables and populate them with data. Let's first create a table called fruit sap. Let's run this and there you go. Refresh it and now we can see it here. Let's also set it as the default database. So use fruit sap and run. And there you go. MySQL will now use this database from here on out. This code here is to create the table, so nothing complicated. As you can see, they are simply create table queries with 2 columns and 2 queries to populate the tables. So feel free to highlight all of this and run it. And there you go. Now we have everything set up. Now let's select all the data from Sarah's table and we can see it's all there. Let's do the same for Ibrahim. Let's run it and yeah, we can see we have all the data that we need. Now, a question for you all. Do you think it's possible that using only one select statement, we can select all the columns from 2 different tables? Honestly, no. And let me show you what happens if we write one select statement to select all the columns from 2 tables. So let's write select column B and this one here. And from Sarah, we'll select column A and this other one. Now, select them from, well, which table? Unfortunately, it only lets us select from one table. If we add another one, it'll run an error. So let's run it and see. There you go. Error. To solve this, we'll use the magical join keyword. So we'll join data from 2 separate tables. Let's highlight this and run. And wonderful. Now we have all the details from all these columns in one place. We can see that there are 4 columns total and it selected everything. But the data seems to be duplicated. It seems that for every row in the first table, it brought all the data from the second table. We can see that in the numbers that all the data is repeated. Now, do you think that just by using join we can solve our task? Not at all. Not only does it duplicate the data, but we only need the ones that are repeated between both tables. So, how do we solve this? In order to make the join effective, we need to use the on command. So basically, what we need are the things that are in table A that are equal to the things in table B. So after this join, we use on to specify where we want the join. So we go on this table equals to this table right here. Let's run this and see. Wonderful. This is the data, the exact data that we were looking for. So what did we do here? We did something called an inner join. Basically, we asked MySQL to look for everything in table A that is also in table B.